Hey everybody, this is Alex Merced, Senior Evangelist at Dremio, and in this video what I want to do is talk about the difference between views, materialized views, and Dremio's reflections. So the goal here is that by the end of this video, you should have appreciation for these three concepts and how they differ. Okay, so first let's just talk about views and materialized views. These are features that you generally are going to see in most database, data warehouse, data lake systems. They're just sort of kind of come with the territory. So imagine that you have tables. Okay, so here I have a sales table. Okay, now what's going to happen is that I may run a query on that where I'm only looking for a particular month's sales. So I may do something that looks like this. So, select star from sales where month equals, let's say June. So we'll pretend that's a 1 through 12 count. So we'll say 6 for June, and year equals 2024. Okay, so I'm looking for all the sales that are in 2024. Okay, so there's my query. Okay, and that gets me every sale that's in 2024. Now here's the thing, I don't want to have to type in that query over and over again. Okay, so then what I may do is create what's called a view. Okay, and what the view does is that basically what I'm doing is I'm pre-saving that SQL under a name. So instead of me having to type out the whole query, I now have something called maybe, June 2024 sales. Okay, and that's the name of the view. Okay, but it's not like its own table. I didn't make a copy of that data. I just now have a name that I can query to get that specific data. So now going forward, what I can do is I can do like select star from June 2024 sales. And now when I do this, it's essentially going to run this query, but now I don't have to type out that whole query. This is going to give me specifically what I need, that view of the data. Okay, and that's fine and good. And then I can use that to now delve deeper. So now I might end up doing a query that looks like this, like select star from June 2024 sales, where total is greater than 100. Okay, so now I may want to do this. So now I'm saying, hey, and I'm going to basically, hey, this may be a view or a query that I run very often. So I make a view of that. Okay, now I have, we'll call this June sales over 100. Okay, and that's going to be the name of that view. Okay, now I can go query that view just like I said before. Okay, now the problem is when I still query this particular view, I'm still running a query on the full sales table. So essentially what's going to happen, depending on the different types of database tools, so different databases, different data warehouses will have their own logic for resolving these views when you query them. So, but at a high level, what may be happening is that first it's going to run this query. So first it's going to scan the sales table. So it's going to scan the whole sales table to get June sales, and then take that June sales and then scan it to get the totals over 100. So you're still having to wait for all of that to actually still happen. All I'm really doing with the view is making the writing of the SQL more convenient. Okay, but it doesn't actually improve the speed or anything. Okay, whatever it would take for me to just run that query directly from the sales table is still what it's going to take me to do it here. Okay. So sometimes maybe running this query may not be fast enough. Like running this query directly on the sales table every time isn't going to necessarily be performance. What you do is you create a physical copy of this data result set. Okay. So what I'm going to do is I'm going to say, hey, you know what? I want to take this query and I want to take the results of this query and create a new table that's an actual physical copy of just that data. And we'll call this June sales over 100 materialized. Okay, Notice I'm not putting a query here because in this case, I'm not saving the SQL. What I'm doing is I'm taking the results of this SQL and literally making a physical copy over it. So I'm literally making another table that's called a materialized view because it's the result of another SQL query. Now, what goes going forward, if I want to have a faster query, I don't write. So for example, if I write this, select star from June sales over 100, okay, then what's going to happen? I'm still going to be querying this view, so I'm still going to end up querying the whole sales table. So I'm still going to get the slow version of the query. So in this case, I have to understand that if I want better performance, I have to make sure that I query the exact name of the materialized view. Okay, so I could easily forget to do that and end up doing this lower query. Okay, so that's one of the problems with materialized views. Okay, so there's the fact that I need to make sure to update my queries to take advantage of this new thing that was created to speed up my queries. Second potential problem is the thing is that this, in many systems, and again, it's different from database and data warehouse system and different versions of these systems, but oftentimes this materialized view does not automatically update. So as a sales table updates, this data becomes stale. It no longer reflects the actual sales data. So this means I need to come up with some sort of way to refresh this materialized view. Okay, and this oftentimes can be a little complicated because it's up to you to sort of manually figure out this logic. You know, you might just do a full refresh where you just rerun the query and generate the results again. You might create things that are called like write ahead logs or other types of sort of ways to kind of capture changes. Okay, and then basically update the materialized view based on changes. And again, different database systems have these kind of things built in. Okay, because they're enclosed systems. Like they understand their tables. So in that case, you have to figure that out. So again, you have two problems so far. One, it creates this whole new namespace, this new name that I have to query, which means my analysts have to be aware of the change. I have to be aware of how to get the best. So the idea is I have to do more training. Okay. And then two, I have to figure out how I'm going to keep this materialized view in sync with the underlying data. Okay. So that's a materialized view. Now let's take a look at what Dremio Reflections does. Now, the cool thing about Dremio is that you're not working with a single database or a single data warehouse or a single data lake. So this sales table could be on Postgres. The sales table could be on SQL Server. A sales table could be in Snowflake. This sales table could be in an iceberg table on your data lake. It doesn't matter where it's from. You can connect to Dremio. Okay? And just like before, you can create views on it. Okay, so that doesn't change. We're using Dremio. But what happens now is instead of creating a materialized view in Dremio, okay, what you would do is you would create a reflection. Okay, so in this case, we'll create what's called a raw reflection. And what the raw reflection does, it doesn't matter where the original sales table is, you're going to have a data lake that's connected to your Dremio instance. Okay, so this is your data lake that's attached to your Dremio, which could be, again, an on-prem data lake, so Hadoop or MinIO. It could be a cloud data lake with like a S3 or Azure or Google. But whatever it is, what it's going to do, it's going to create an iceberg table. Okay, it will create an iceberg table. So I should make that maybe a little bit smaller. Okay, an iceberg table copy of this. Basically, in the same way that a materialized view would create a copy of the result, I'm taking the copy of this result, but not making it as the original source format. So it could be a Parquet, whether sales is a Parquet table, a Delta Lake table, a SQL Server table. It doesn't matter what the original table is. It's going to create an iceberg table sitting on your data lake. Okay, and the beauty of this is you get the benefit of the materialization. So that means you get the copy, okay? And that is going to speed things up because I'm scanning a smaller subset of data versus the larger sales table. But the thing is that iceberg tables also have a bunch of metadata, okay? And that metadata can be used to scan that copy of the data much more smarter. So that metadata acts as an index. So essentially, it's not just a copy of the data, it's also an index on the data. So you're getting 2 layers of improved performance on the data you're scanning. So on that subset of data, you get the improvement, the performance improvement in 2 layers. So that's cool. Okay, so right there, that's pretty nice. Like these reflections are really built to be faster than probably just a pure materialized view on the original source system would have been, because of the neat design of Apache Iceberg. But you get a couple other really big benefits that are addressed from before. So we had 2 problems, right? We created a new name. Now in this case, when you create a reflection in Dremio, it does not create a new name. There's no new table. There's no new thing. What's going to happen going forward is that if I were to do a query of select star from June sales over 100, so now I'm querying the view, Dremio is aware, because this is all built into Dremio semantic layer. So because you're curating these views on Dremio semantic layer, and these views have reflections created on top of them, Dremio is aware of how these things relate to each other. So when I query this view, Dremio is aware that, hey, there is a reflection that was created on this view. Maybe I should use it. And then it will consider it and determine, hey, is this actually faster? And if it is faster, instead of scanning the original sales table, it'll scan the reflection that it created on your data lake. Okay, so in this case, the analyst doesn't even need to know that this thing was created and doesn't need to update their queries. So the likeliness that the analyst is going to accidentally run a slower query is much less. Okay, so in that case, it's taking a lot of the burden off the end analyst in making sure that they're aware of all these sort of different versions of these data sets. Okay. Now the second cool thing is that these reflections will then update themselves. Okay, so you can actually set a cadence, like maybe it updates itself once a day, or it updates itself once an hour, or more frequently, and it will update itself. So in that case, you don't have to worry about kind of thinking through all the logic of keeping it up to date. Okay, and we're going to get a little bit more detailed about that a little bit later on, when I start talking about some of the more modern advancements of this reflections feature. But just to show you a couple other really cool ways this works. Okay, put that there. Let's move this over here. Cool. Okay. Now, what if instead of creating the reflection on this view, I created the reflection on this view? Okay. Now, what's going to happen is that if I run this query, Dremio knows that the June sales over 100 view is still based on the June 2024 sales view. So in this situation, Dremio will still be like, oh, well, the parent view has a reflection based on it, and would still see if maybe using the reflection on this particular view will speed up running the query that you wrote on this particular view. Okay, so basically what's going to happen is that as you create the semantic layer where you have all these views and child views, you can strategically place reflections where they can not accelerate just one view, but they can accelerate multiple views. So now any view created based on June 2024 sales may be accelerated based on this reflection. Okay, so this can be really useful if you have like intermediate views that create joins and things like that. So that way you can pre-compute the join and then create all your views based on the joined data or denormalized data. So these are some ways you can use that. Now, another situation you might have is that you may have like a BI tool. Okay, so let's create a BI tool over here. Okay, now with the BI tool, you're going to be generally displaying graphs that are going to be the result of queries that do like group by, So, you're saying, hey, I want to take a look at all sales group by month, all sales group by customer. Okay, and so these queries are what's referred to as aggregate queries, where you're trying to take a look at the average, the min, the max of these types of calculations. So not only does it have to pull the data, but then it has to run these calculations, averaging out like the sales for every, or the total for every sale, or something like that. These can be, for really large tables, these can be really long taking calculations. And again, keep in mind that the Dremio engine is very, very fast. So a lot of the situations, you may not even need reflections because Dremio's raw speed will be more than fast enough, even when you're virtualizing across multiple different types of sources. Okay, Dremio has first-in-class performance out of the box. This reflections feature just gives you a little bit more when you need it. Okay, and one of the things to help you with that is that Dremio has a reflection recommender that'll recommend you reflections based on the activity in your Dremio cluster, so that way you don't have to like magically figure that out. Dremio can basically help give you hints on where these reflections can be best used and which reflections can then be eliminated. So that way you can free up that storage space. But again, the idea is that Dremio is going to try to determine when is the extra storage going to be more valuable, basically save you money versus the extra compute of not having the materialization. Because again, there's always this trade-off between storage and compute, but reflections, again, Dremio takes a lot of the work out of that, and that's the beauty of it. Okay, but another type of reflection I can create, okay, is called a aggregate reflection. And an aggregate reflection isn't just making a copy of like the rows, okay? It's making a copy of certain aggregation. So this is very similar to what's referred to as a cube or a BI cube in many other tools, or BI extracts. Okay, actually technically probably like the raw reflection would be more similar to a BI extract, while, where you say, hey, I'm going to make a copy of this data for my report. And then a cube is going to be more like you're literally creating a data set that just has the aggregate calculations that can then be used to speed up, because you don't have to redo the average by customer because you already have those numbers ready. So that's what this is doing. And again, it saves it as an iceberg table on your data lake. So you're getting that same benefit where you get the more physically optimized version of your data, but that has this metadata that acts as an index. Okay, so that's the beauty of iceberg tables. They're essentially a table plus an index when you really think about it. So now if I were to run, plug in my June sales over 100 view directly into my BI tool, what's going to happen is that when the BI tool sends queries over to Dremio is going to realize that, hey, these are aggregate calculations. These are by dimensions and measures that I have optimized in this reflection, and then substitute the reflection for much faster performance. Okay, again, very valuable when you're talking about really large data sets and you're running really complex aggregate calculations on really large data sets. Okay, and then really speed up that BI dashboard, so that way you get sub-second latency. Now, this is all really good, but what happens if you're refreshing a really, really large table? And again, this is the problem whether it's a materialized view or reflection. If it's a really large table, refreshes, meaning rebuilding the materialization, can take a while because you're rerunning a query on a very large data set. Now, one of the nice things that Dremio has added on recently is incremental reflections and live reflections. Now, this happens if your original data, so basically this takes advantage that if your original data, so your raw data, your original table is an iceberg table, that there's metadata involved. And with that metadata, Dremio can do some extra fancy things. So this is just kind of emphasizes why it's a good idea to have a data lake house that uses iceberg, because using those iceberg tables, you get extra reflection powers. Okay, one, when the reflections update, it can update incrementally, which means instead of rebuilding the whole reflection, it'll only add the changed data. Okay, so it's going to be much more lightweight, which means it can refresh those reflections much faster. And two, you have live reflections. Since Dremio is going to be aware when that iceberg updates, because it's much easier to pull the catalog and see, hey, is there been a change of metadata location, Dremio can then basically trigger these refreshes when the table changes. So in this case, this makes it easier for you to make sure that not only that these reflections are refreshes are lightweight, but that they happen when they need to happen with as minimal work as possible. You just basically turn these features on, and essentially anytime the table changes, the reflection changes. And when that change happens, it's going to happen very lightweight at a very low cost, allowing you to have that really good performance with very minimal trade-offs versus your traditional options for handling these types of situations, which are materialized views, cubes, BI extracts. And the cool thing again is that Dremio connects all these tools. So unlike using extracts, they're not stuck in your BI tool. So if you have one team that uses Power BI and another team that uses Tableau, they're not both having to make separate extracts. Okay, so you're not redoing the same work twice. And because Dremio has a semantic layer, you're defining all these views and whatnot in a way that everyone can use the same view to define the same metric, the same data, the same way across multiple tools, making their life a lot easier across this semantic layer that you curate over all your different sources of data, whether they be databases, data warehouses, or data lakes. But hopefully this helps explain reflections a bit more for those who are looking to get a deeper understanding of how reflections work. But otherwise, I'll see y'all later. Have a great day and enjoy.